Today we are talking about water pressure with flat surfaces, curved surfaces, and varying widths. So, in the flat surfaces, we have the slope, and the width is always constant. And for curved, the what is it called?
The equation for like the depth.
The equation for the depth is an equation, yep. And the width is always a constant. And for varying widths, the depth is an equation and the surface is an equation. And so this is our equation for force. It is basically the volume of pressure because water times density is basically area. And then depth is multiplied by both of them. And this is in all three of the equations. I think that was all my part.
Yeah. So the main part of this is going to be with integration. And as Tatum was saying, for our force with our P, G, and Z, our P and our G are always going to be constant, but our Z for our depth is what's actually changing. So we'll have a slope, an equation for our F. So what that means is that this is going to be some sort of constant or with one variable. This is going to be with variable squared or some other type of variable, and same thing here. And those are all being multiplied by our width in here. And if our width is just constant, we can actually move our constant out in front of here, just properties of integrals. But if it's an equation, we have to remember to keep it in here because we're also going to integrate with that second equation. So once you get this set up with PGZ and your constant width, you have two parts of integration. Since it's water pressure, we're thinking about our entire surface under the water. So our positive y is actually going to be here, and our z is going to be over here. We're thinking about A and B and C and D. So the first part we're integrating is we're thinking of our slope. So we're integrating with d of x. So we have this here. We're going to have, the first part we're integrating is our width with d of x. So we're going to have x here with some sort of equation down here, or it's just going to be constant number. And as shown down here, we'd integrate that, so we'd have an x, and then we'd take the difference from our c and d. And then this second part, we would do with all the equations, where we have the integration between a and b, and that's the depth of our equation with our second integration. So first we're going to integrate our width, if it's an equation, and then we're going to integrate our slope. And the important part to remember about this is when you're integrating, it has to be in terms of x if you're doing it with d of x, or in terms of y if you're doing it with d of y. And that's just important to look at it from these two perspectives, kind of from the side if it was going into the paper for these, or just from the front if it was looking at it from the side. So that's about it for those. It's the same equation, just either equations or constants.
Thank you. Have a great night.